Okay. So we did everything. So what's the work done by the total work done on the grid? Total work done is
Sum of all the works.
sum of all the works. Is that right?
Yes.
Okay. This is all done. He has also done this question in his own way. You can do it. Just say total work done 600 joules plus 0 by normal reaction plus 0 by gravitation force plus minus 480. That's work done by frictional force, and altogether comes 120 joules.
Yes.
Should I tell you how to find directly this work done by total work done?
Yes. Yes, please.
Okay, see here. This is the object.
Yes.
This is the force. This is the frictional force. This moves up to here. And it is the d distance. This is normal reaction. This is mg. These two will not do any work. Work done is equal to F net into d. What is F net?
Force minus frictional force.
Good. Into d. That is Fd minus Fd. That is, this is 600. It's 480. That is 120 joule.
Got it.
Is that right?
Yes.
Okay, let me go to something else. Now he talks about third example. He talks about a block inclined plane with a theta, and here is the block at the top, and it falls off at distance d, right?
Yes.
It has mass m. It falls down, right? We have to find. Let me see what he asks us. He asks the work done by gravity. Work done by gravity. Then he says work done by normal reaction. Then he says work done by friction. Then he says total work done. He asks the same number of questions, but he gives coefficient of friction. He gives to be 0.4. He gives d distance is 10 meters. He gives theta is equal to 30 degrees, and he gives mass to be equal to 20 kg. He asks all these questions, and also he solves them, and he has all the answers with him, right? Should I follow his approach, or should you give you my own approach?
Your own approach.
Okay, that is good. Obviously my approach will be short and it will be quite lucid. The body
Yes.
it falls from here to here. Okay?
Yes.
How much distance it covers? D.
10 meters.
D. It covers D. Okay. What is this force? mg? Vertically downwards towards the ground? What is this?
Normal reaction.
It is normal reaction. That's very nice. Perpendicular to the plane. Can you resolve this into components?
Yes.
This is theta and this is also theta. What is this component?
mg cosine theta.
Good. That's very nice. That is good. And what is this component?
Mg sine theta.
Mg sine theta. The body does not cross the incline. Therefore, n equal to what?
Mg cosine theta.
Okay, let me write. N is equal to mg cosine theta. Although we may not need it, but it is good to write. So what is work done by gravitational force? Look here, mg sine theta, is this force gravitational force? Along the inclined plane it moves. What distance it covers?
D.
So what should we write? mg sine theta?
Mg sine theta D.
That is d. There's no need to write dot or anything else, because force and this displacement is in the same direction. That's why we just multiply them. You already remember, if force and displacement are in the same direction, we just multiply them.
Right.
And it is m is 20, g is 10, sine theta is 1 by 2, sine 30 is 1 by 2. If you don't remember it, I tell you. And d is 10. This is the answer by multiplying. If you want to answer, this is finished, and it is 10, 10, 10, that's 1000 joules. Is it difficult for you to understand?
No.
No, it shouldn't be. Mg sine theta into d is the work done by gravitational force. What is the work done by normal reaction? This?
Mg cosine theta.
No, 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 no. See the displacement direction.
Oh, yes. Okay, yes.
See the normal reaction.
Yes.
And what should be the work done?
0.
Good, that is right. Is it difficult now to understand?
No.
What is work done by frictional force? Now see here. The body moves like this down the plane, and frictional force acts like this.
Opposite.
How much is the frictional force? Mu n. When the body is in motion, if you remember that, if a body is in motion, the frictional force is mu n. Mu kinetic friction into kinetic frictional coefficient into n. Remember that.
Yes.
Because one needs to revise things again and again, otherwise you forget. I had already told you, if a body is in motion, this is the frictional force. The body goes down, this is the frictional force. So it is mu. What is n?
Mg cosine theta.
Mg cosine theta. Now, what is the work done by frictional force?
Mu g cosine theta D.
Look at this and look at this day. This is force, this is displacement. First of all, negative sign.
Yes.
Why? Because frictional force is opposed to the displacement. Displacement is downwards and frictional force is upwards. So it is mu mg cos theta into d. If I multiply, mu is 0.4, m is 20, g is 10, cos theta is cos 30 root 3 by 2, and d is how much? 10. If you multiply these things, you will get the answer.
Okay.
Now, what is the total work done?
The sum
of the works. That is this 1000 joules, that is positive work, minus this much.
Yes.
And that will give you the answer. If you ask me to find it directly, I will do it like this. Work done is equal to F net into displacement. F net is mg sine theta down the plane minus
Mg F net.
F net.
Yes.
Mg
Cosine theta. Mu mg cosine theta.
cosine theta
Times D.
mg cosine theta. This force minus this force. These two forces cancel, and then this cancel. This is resolved into two pieces, this and this. This goes, mg goes, it becomes this and this. This normal and this goes, and there remains this and this. This is this minus this. Okay?
Yes.
I will repeat again. This you make two pieces, this piece and this piece.
Right.
This piece and this piece are equal and they are opposite finishes off. It is this piece minus this piece is the net force into D. That is the net work, total work done.
Yes.
This is all gone. We did it our own way. He may have done it his own way, but the answer is the same, right?
Yes.
Okay. Now he also gives one example on area. He writes like this, makes a diagram like this, and he says it is force, and he says it is displacement x, right? Then he says, what's the work done? And he gives the answer, work done is this area, right?
Yes.
Not a big deal. Okay. Then he goes to power. What is power? I'm following your book, right?
Yes.
I'm just following your book. And he says power measures how fast you do the work, and then he says so many things, and then he does so many things, and finally I must tell you something what I mean. What is power?
Okay.
Should I teach you power my own way?
Yes.
Okay, see, what is power? Power is basically rate of doing work. Simply, power is how much work you do in 1 second.
Yes.
That is work by time. You may do a lot of work, but that never means you have a lot of power. If you do more work in less time, only then you have more power. If you run on a jogger run, if you run on the jogger run and you are running very fast, then your power is more. Suppose you run the whole day, you are doing a lot of work, but over a lot of time. If you work, if you do more work in less time, then your power is more. That's why it is rate of doing work. Suppose you see, okay, I will tell you one thing. Suppose there's a book here and you are getting this book to this shelf, to a height of h. How much work you have done? You have done work of mgh.
Right.
Mg is the force and h is the height. Okay, mgh is the work done. Suppose you do this work in 10 seconds. So power is equal to mgh by 10 seconds. Suppose you do the same work in 2 seconds. Who has more power?
In 2 seconds.
Yes, that's it. So power is how much work you do in 1 second, or how much energy you gain in 1 second. Energy gained in 1 second. You may even lose energy in 1 second. That is dissipative power. You may get some energy in 1 second. That means you are being delivered energy, power. You are being delivered power. You see, we have lamps here, electrical lamps like this. I don't know whether you have them there in the United States. There is written, what there is written on the lamp here, they are what you call as calibrated, or they are what you call as that labeled 220 volt, comma, maybe 100 watt, maybe 100 watt. This is the labeling of the lamp. That means, what do you mean by 100 watt? That's power.
Yes.
Unit for power is equal to work by time. That is joule by second. Because work is joule and time is second. And that is nothing but one more watt, W. But this W is not the same as this work. This is watt symbol, right?
Yes.
So power is how much work you do in 1 second. How much energy you even lose per second is dissipative power. How much energy you gain in 1 second. How much heat you lose per second. Dissipative power. Power is just energy by time, work by time, energy by time. That's all.
Okay.
So sometimes dissipative power. That means how much energy you release in 1 second. And there are so many things also. You see, there's one more unit for power, that is horsepower. 1 horsepower is HP that is 750 watt. And 1 watt is 1 joule by second. This you should remember, right?
Yes.
Okay. Suppose if power is, you see, work done by time, can you tell me what is work done? Power into time.
Yes.
So if you are given power and you are given also the time, then you multiply the two, get the work done. There is also one more formula for work done. Suppose you are given power and then you are given also the time.
Yes.
If you multiply power and time, you get what?
Work.
Okay, that's right. Now, okay, you know, work is equal to F dot S.
Yes.
I have not seen in this book, in this dot, they simply say FS. Yeah, okay, F. No, पहले तो शायद दिया है. हाँ, पहले दिया है. डॉट का नाम यूज नहीं किया है, शायद वेक्टर से डरता है.
Maybe.
कास्ट मगर लिखा है नहीं.
Yes.
You don't have vectors in your syllabus?
Vectors only the first chapter.
Oh, okay, but if you know the vectors, then you must know what is the dot product.
Yes, I think went over. I don't think they went over dot product, but I think I remember.
Dot is they define as A dot B is AB cos theta.
Yes.
And A cross B something like AB sin theta.
Right.
If you remember it. If you don't remember it, okay, I will do it other way around also. Then I don't need to write dot. I simply write Fs cos theta.
Okay.
That will do, but I don't know whether you do it in your school syllabus or not, because vectors are very important. Vectors, one has to start with vectors.
Yes, they do teach vectors.
No, vectors in full detail, not components and all these things, okay?
Oh, yeah, they only talk about components, vector components.
Okay, now see, this is work done is equal to F dot S. Now, what about delta W by delta Ti, right? So what should I do from the right side? F dot delta S by delta T. No, you don't follow.
No, I think I get it.
Okay. You think you don't.
No.
Let me write once again. Work done is equal to F dot S.
Yes.
If I divide by time here, I will divide by time here.
Yes.
This is power. Isn't?
Yes. Yes.
And F is there. Dot, what is displacement by time? That is velocity.
Velocity.
So power is F dot V. If you have a dot product of force and velocity, you get again power. But your books, maybe they write only P is equal to FV cos theta. They don't mention this dot, they write FE cos theta.
Yeah.
That means if force, but theta is what? Angle between what and what?
Displacement and
force. This is
force and velocity.
Yes, force and velocity. That means if theta is 90, power is 0.
Yes.
This means if force is acting on an object, but that force is perpendicular to velocity or normal to velocity, then that force will not create any power.
Yes.
That force will not do any work. So why should it create any power? After all, power is work done by time. When it is not producing any work, how can there be any power?
Right.
Okay. If theta is 0, then what's power?
Maximum.
FV, yes, that's right, good. If theta is 180, I mean when force is opposite to velocity, particle is moving like this and force is dragging it backwards.
Negative.
Negative power, yes. What do you mean by negative power? That means you are reducing it as energy.
Yes.
Because when force is backward, particle velocity is forward, its speed will decrease. When its speed decreases, that means its kinetic energy decreases. That means it loses energy.
Yes.
How much energy it loses in 1 second is power.
Yes.
But that power is not delivered to the object. Instead, the object loses. Object delivers power to something else.
Yes.
Because when object delivers power to something else, it's the object which loses energy. And it delivers power to something else, that something gains energy per second, right?
Yes.
Of course, the energy it loses per second will be the energy the other object gains per second.
Right.
You see, if there's a force on this object in the backward direction, who creates this force on this object in the backward direction? Somebody
Friction.
may have.
Yes.
Somebody may have.
Yes. Or
What-
friction. Or
what is the force on that somebody due to this object?
The reaction force. So
Yes, that reaction force will increase the energy of that object.
yes.
So it loses energy per second, that gains energy per second. If there's a conservation, so whatever energy this object loses per second, that will be the energy that object on which there's a reaction force gains per second. Obviously,
Yes.
the energy has to be conserved. So this is all about, if you concentrate on this equation, good. If you have a slight background of vectors, then this equation is no bad. It is also equally good equation. This dot means this whole. You can understand this is a symbol for this. If there's FV cos theta here, and somebody writes F dot V, he means it is FV cos theta. So it is a symbol, or it is a
Yes.
representation of this. It means the same thing. If you look somewhere, it is A dot B, you look somewhere. You say, yes, it must be AB cos theta. And the person may not have that time to write it like this. He may have written it like this.
Yes.
Okay. That was power. Okay.
Yes.
Now, let me go to another concept. Now, he gives an example here from your book.
Yes.
The example is 100 joules of work is done over a period of, over a time interval of 2 seconds. What is the power? Number one, what is the power? We have to find the power, right?
Yes.
And then he says, how much power must be provided to a model rocket of mass just to keep it moving upward at a constant speed of 40? Yes, it is another question. First, let us solve this question, then I will solve another question on this, right?
Okay.
Power is nothing but W by T.
Yes.
We prefer to write delta W by delta T, right? But your book writes W by T. Delta W is 100 joules.
Yes.
And times 2 seconds. It is 50 joule per second. That's 50 watt. Easy. No?
Yes. Yes.
Okay. Now there's one more question he says in the same, because he writes continuously. Better would have been if he separates the question from one question and another question. He writes continuous messes up. Anyway, but I can make out that he wants to ask this question. The question is, how much power must be provided to a model rocket of mass 50 kg? There's a rocket here, 50 kg mass. To keep it moving, we want to keep it moving upward with what velocity? 40 meters per second.
Okay.
Ignoring the resistance. The engine thrust must provide an upward force that is equal to the weight of the then this, then this, then this, then this. Okay. What his question is, how much, what is the power? What is the power required? ठीक? How much power we need to move the rocket upwards with a constant velocity of 40 meters per second. The rocket has a 50 kg mass.
Yes.
This is our question. Just try to absorb the question for a minute, right?
Okay.
Then I will give you the solution in a better way.
Yes.
Then I will give you the solution. Okay?
Yes.
Should I give you the solution?
Yes, please.
Okay. That's right. See here. Can you remember what I told you? Power is equal to Fv
Yes.
cos theta.
Yes.
Theta is angle between what and what?
Force and velocity.
Yeah, that's nice. That's right. Is a rocket?
Yes.
Its mass is 50 kg.
Yes.
How much is the force downwards? mg.
And
With what velocity you need to move it up?
40.
40 meter per second.
Yes.
That is lead. How much force you need to give in the upward direction to move it with a constant velocity?
A normal reaction.
No. Normal reaction is when it is on the ground.
Okay.
My question is simple. If you need to move this rocket upwards with a constant velocity, how much force you need to create in the upward direction? That's my question.
Okay.
Give me the answer. If you don't give me the answer, I will give you the answer, but then you will remember it all the time.
Okay.
How much force I need to give it in the upward direction so that it moves with a constant velocity upward. Good.
Force equals ma. So acceleration. Mass. So
How much force I need to create in the upward direction so that the rocket moves with constant velocity.
this is going to be ma plus mg or something. 1/2 mv squared. That's energy.
Should I give you the answer?
Yes.
Will you remember it all times to come?
Yes.
If it moves upward with constant velocity, any rocket moving with constant velocity, what is the net force on that?
0. Or,
Yes, you are right.
okay.
What is the net force?
0.
Therefore, upward force should be also mg. Applied force, mg. So that there is no net force. That is why it moves with a constant velocity. So anything, any object, if it moves with a constant velocity, the net force on that must be 0. You already know there's a downward force of mg. So you have to create equal amount of force in the upward direction so that it moves with a constant velocity.
Yes.
Now you understand?
Yes.
Okay, now see, I will show you other way around also. Suppose the upward force is this F, right?
Yes.
How much is the downward force?
Mg.
So there's upward. What is upward acceleration?
0.
That because it moves with constant
velocity.
Okay. So what is the force equation? F is equal to ma equation. Bad
Yes.
guys on the left. What are the bad guys? F net.
Mg.
F minus
F minus Fg.
F. I have to
Okay.
prove this F is equal to mg, na? That I have to
Okay.
prove.
Okay.
Let me say I am applying this force F.
Yes.
So what should I write for F net?
F net is Mg minus F minus Mg. Or
Yes, F up, mg down, right? That is the F net. Is equal to what?
Ma.
That is 0. A is 0 because it moves with constant velocity.
Right.
So F minus mg is equal to 0. So F is equal to mg.
Yes.
Isn't that? So when the rocket moves upward with constant velocity, that means the net force on it is 0. But you already know mg is downwards. So you have to create equal amount of force in the upward direction so that it moves
Upwards.
with constant.
Velocity.
If you create acceleration in the upward direction, that means this F should be more than this mg.
Yes.
So that there's net force.
Yes.
Okay. What force you are exerting? This or this?
The top one.
Top one. Oh, that's good. See, I will write an equation and that will give you the answer, right?
Okay.
Have a full concentration what I write.
Okay.
Okay, cos theta also. Okay, what is the angle between this force and this velocity?
0.
Say confidently, it is F, it is velocity 0. Obviously, that F is mg to V.
Yes.
It is m is, how much was the m?
50 kg.
It's 10, it's 40, 2000,
Yes.
20,000. What? Answer. So it is the way, the lucid way of doing the things. You see, now you have got the formula of power is equal to Fe, it is mg into V, and then you substitute the values, get the answer.
Right.
Do you understand what I say?
Yes.
Basic, simple principles of physics and nothing else.
Right.
Okay, let me see what else he asks. $20,000. Joule, what? It also means 20. This is kilowatt. Do you understand that?
Yes.
Because 1000 means kilo. Maybe it is kilogram, maybe it is kilowatt, maybe it is kilo. Anything kilo means 1000, right? So this you replace 3 zeros by K. Do you understand what I say?
Yes.
Now he talks about kinetic energy and work energy theorem, which you have done.
Right.
Now he asks an example here. Should I do that example with you? Should I do that example?
Sure.
The example says, example is, it is 6-8, something like. He says an object, he has written a long thing here. I don't know. He has written a long statement, but I want to put it in a very simplified manner. He says there's an object. Mass is, okay, 10 kg, and its velocity is, okay, initial velocity is 4 meters per second towards north. What is its kinetic energy? इसका kinetic energy निकालना है.
Okay.
What would happen to the kinetic energy if the speed of the object is doubled? What happens to kinetic energy if speed is doubled?
Yes.
That is what he says. Okay? Okay, that's good. I will solve this problem for you.
Okay.
And then let me see, is there any other problem he asks?
Alright.
He says, recall this centrifuge example 4.5. I don't know 4.5 example. Maybe it is in your book at earlier page. I can't refer to that right here.
Okay, I have.
If it is you have a figure 4.5, then I will do this problem.
All right.
Okay, let me do this problem for you first.
Okay.
Look at this. A very interesting thing, what we need to learn from here. First of all, he says, see, he says that velocity is 4 meters per second, right?
Yes.
In the north direction. If I make these, it is east, west, north, south. Particles moving like this in the north direction with 4 meters per second.
Yes.
He says, what's the kinetic energy? First of all, you must know kinetic energy has nothing to do with direction.
Okay.
It is the first thing. Maybe he has mentioned this not to confuse the student or to tempt him to make a mistake. Maybe it is north, maybe it is south, in any direction. Kinetic energy has no problem with that. Kinetic energy has only the weight is 1 by 2 mv square. Square is always a scalar. So why we bother about the direction? 1 by 2, it is 10, it is v square 16, it is 80 joules. Answer.
Yes.
Then he says if speed is doubled. If speed is doubled, it is this which doubles.
Yes.
Kinetic energy becomes 1 by 2 m 2v whole square.
Yes.
Because it is this speed which is doubled. Square will be both of it, right?
Yes.
So confusion may be possibly you will do 1 by 2 m 2v square. That is wrong.
Right.
It is this v has to be doubled. And square is to the both. So it is 1 by 2 m 4v square.
Right.
It is 4 times the same thing, 1 by 2 mv square. That is 4 times 80. That is 320 joules.
Yes.
Answer. Finished. Okay. Do we follow these simple things?
Yes.
Okay. There is one more question. Example. There is one more example. That example is like this. Do you copy these things?
Yes.
Okay. Okay. He gives a statement, a long one. He refers to the example 4.5, but I don't have the example here. But I can make out something from what he says. He says a particle moving in a circle. Oh, sorry, I can't make good circle. It has a velocity v, right?
Yes.
This centripetal force is direction towards the center, Fc.
Right.
Then he says, first of all, he says, what is the centripetal force? The answer is mv square by r, right?
Yes.
M is mass, r is the radius of the circle. This v is square of the speed and r. That's good. Then he says, what's the work done by friction, this centripetal force?
So.
He says, what is the work done by the centripetal force, right?
Yes.
Okay. That is what I can make out what he says.
Yes.
My answer is, whatever may be his question, I don't know, but I can make out what he says. My answer is big zero. Why? Because the angle between velocity and force is 90. It is velocity direction. It is also the displacement direction.
Right. Yes.
Velocity and displacement have same direction. What is the angle between force and velocity here?
Force about 90.
What is the angle between force and displacement?
90.
Because velocity and displacement have the same.
Direction.
So it is the velocity direction. It is also the displacement direction. The angle between. So work done is 0. That's it.
Yes.
And will kinetic energy change of this object?
And 1/2 mv squared.
Will
No.
will kinetic energy change of this object if the work done is 0?
No.
Absolutely. Good. Why? How do you know? I will tell you how do you know. Work done is equal to change in kinetic energy.
Yes.
Like K2 minus K1. When work done is 0, that means K2 minus K1. That means K2 is equal to K1. That means kinetic energy does not change.
Yes.
So you can write it. If there's no work done, but I will write our statement. If there's no work done, kinetic energy remains constant.
Yes.
Remember as many statements as possible, right?
Yes.
Okay. Now there's one more question, one more example. He says a box of mass 4 kg is initially at rest on a frictionless horizontal surface. The horizontal force F of magnitude 32 is exerted on the object and then removed. If the speed of the object is 2 meters per second, over what distance did force act?
Yes.
Now see, I can't write the whole statement what he says, but I can give you the number here 612.
Oh.
I can say, well, I can make a box. This box has a mass of 4 kg. And then he says initially it's at rest, initial velocity is equal to 0.
Yes.
Then he says you are applying a force F on it.
Yes.
Then he says it is frictionless, no friction. Don't bother about the friction.
Right.
Then he says this force has a 32 Newton magnitude.
32 newtons.
And it acts and particle goes in the forward direction. Then the force is removed, right?
Yes.
Force is removed. And finally, this object has velocity how much?
2 meters
per second. He says, over what distance the force acts? We have to find this d.
Yes.
Over what distance this force acts? ये फोर्स डी पर डी डिस्टेंस तक एक्ट हुआ और फाइनली इस पोजीशन पर फोर्स रिमूव हो गया. ठीक, हमें ये डी निकालना है. Is that right?
Yes.
Okay. That is good. Should I solve the question for you?
Yes.
By his method or by my method?
Your method.
Thank you. Is my method better?
Yes.
Okay. Okay, you just concentrate on the question for 2 minutes. Let me have a pause.
Right.
Will that be good?
Yes.
Let me have a pause for a while.
All right.
Okay?
Okay.
Should I solve the question?
Yes.
Okay, I will solve the question. You see, Fatma, I will solve the question.
Okay.
And I will not talk much. Solving the question, I will not talk much. Let me see if you can understand.
All right.
Do you understand?
Yes.
Honestly?
Yeah, I think I do. I do.
See, okay, let me explain,
All right.
but in very less number of words. Work done is force into displacement,
Yes.
F into T, same direction,
Right.
also equal to change in kinetic energy.
Yes.
It is final kinetic energy.
Right.
It is initial kinetic energy. Initially
Right.
velocity was 0.
Yes.
That's 1 by 2. Mass is 4. Speed is 2 finally.
Yes.
That is Fd is equal to 8.
Yes.
D is equal to this by this, 1 by 4 the answer.
Right.
Okay?
Yes.
Now you can do these small questions if you are asked there.
Yes.
Okay. Let me go to one more. Because you see, I have a pause so that you have a better concentration on the question.
Yes.
Because physics is, you do your physics, I do my physics. Physics is not, I can't do physics for you. Neither you can do physics for me. You think, it is independent thinking about the situations, right?
Yes.
So that's why I have a pause and ask the student to concentrate for a while. Okay. He says, consider the block described in example 6.3, which I don't know. 6.3 example, what was that 6.3 example? If the initial speed of the block was 20 centimeters, is the block speed when it reached the bottom of the ramp? It should be something like a ramp where the particle falls down and then final speed. I don't have the figure even for the question.
Oh, okay. I have it. Yes, it's a ramp with the mass sliding down. Angle is angle is 30 degrees. Distance is 10, and kinetic friction coefficient is 0.4, and mass is 20.
Okay. Is it like this? Is it like this?
Yes.
Okay. Explain me. You just explain me. I will solve the question.
Okay.
What is this distance?
Distance is 10.
Okay. Then
Mass.
object falls from here.
Yes.
It falls down, right?
Right.
And what is frictional coefficient mean?
0.4.
What is M?
M is 20.
Okay. Anything else is given?
Angle is 30 degrees.
30 degrees. Okay.
Yes.
Anything else?
Nope.
No. Okay, that's good. That's good. Now see again, what he asks us. What does he ask finally? For
example 6.3, it says what is total work, but for
what is the question? Question is, he says possibly what is the speed of the block when it reaches the bottom of the ramp? You go to the 6.13 example.
okay. Oh, 6.13 or 6.3?
6.13, yes.
Okay, 6.13.
And finally, 6.3 is all right because he refers to that.
Yes. Okay.
But the question he asks us here in 6.13, what is the speed when it reaches the bottom? We have to find what is the speed here.
Okay. Yes.
Isn't it?
Yes.
Should I do it my way?
Yes.
Okay. See, I will tell you how to do the question within no time. What is this force?
That is force M.
What is this force?
Mu K mg cosine theta.
Mu mg cos theta, right?
Yes.
That is because of this normal reaction and then this, right?
Right.
Normal reaction equal to this and this equal to this, right? Okay. Can you tell me how to find this velocity?
Okay.
I will write an equation. I will write a single equation and I will see whether you understand or not.
Right. Yes.
Do you understand anything?
Yes.
I don't think so.
I just derived it, I promise.
Huh?
I just derived it before.
Okay. You see,
Right now.
work done is equal to change in kinetic energy. Final kinetic energy is 1 by 2 mv square here.
Yes.
What is the initial?
0 because velocity.
What is the work done by all the forces? Work done by all the forces. What's the work done by this mg force?
Force by gravity minus force of friction. So mg sine theta d minus mu mg cosine.
So it is m gets cancelled throughout.
Yes.
It is g sine theta d, mu g cos theta d. 2 gets multiplied to this.
Right.
On this side, g is common, d is common.
Yes.
Sine theta minus mu cos theta.
Yes.
Equal to root of 2 into g 10 into d is also 10. Sine theta is 1 by 2 minus mu is 0.4. Cos theta is root 3 by 2.
Yes.
Can you calculate this?
Yes.
Okay, I will calculate it. I will see if can the answer match to some extent. Answer should match to some extent. Okay. It was square, but finishing this square, it is root on the other side, right?
Yes.
If v square is something and v is root of that, it is root of 200, right? No. Why should I? This 2 and this 2 and this 2 cancels.
Okay.
Because this 2 is common here, it will come out and it cancels this. It is 10 into 10 is out of root, it is 10.
Oh, yes.
It is 10 square, it will come as 10, right?
Yes.
1 minus 0.4 root 3. It is 10 root of, what is 0.4 root 3? 0.4 into root 3 is 1.72.
Okay. 0.69.
You just calculate this and see the answer, right?
Okay.
0.4 into 1.72, just multiply and then you subtract from 1.
Yes.
It will be less than 1, I am very sure. This will be less than
0.312. 1 minus 0.4
3, 1, 2. It is root?
Square. 0.558.
0.558 into 10. That is 5.58 meters per second. What's the answer?
The answer 5.6 meters per second.
That's right. That's right. That is the right answer. I think so. Has he given the answer anyway?
Yes, it says velocity is 5.6 meters per second.
Is our answer correct? No.
Um,
Is this answer correct?
yes, I think it is.
It
is.
Maybe he may have written 5.6, right?
Yes, he wrote 5.6.
Okay, 5.8 is as good as 5.6. He has reduced it to the what you call that? To number of significant figures, no?
Yes, significant.
What is the significant figure? Fatima, is it enough for today?
Yes, it is.
Have you learned something today?
Yes.
And inshallah, maybe day after tomorrow we'll do something more. But you need to concentrate more on these topics.
Okay.
And possibly, if other students also need my lecture, I would like to give them the lecture free of anything. If they want to participate in the lecture, it is better.
Okay.
Okay.
So tomorrow is a not lecture?
Tomorrow is what?
No lecture tomorrow?
If you want a lecture, I am ready, but maybe you need you need to give your backup for the lecture.
Okay. Yes. Okay. I will study and then I will